Okay, so we're doing another question 7 of the 2018 specimen paper for the foundation, paper 1. So question 7, without further ado. Figure 10 shows a battery operated remote control car. The car's battery contains a store of energy. As the car moves, energy from one store is transferred to another store. Describe how different stores of energy change as the car moves. Okay, so when we're talking about stores of energy, it's good to remember the definition of energy. Energy is the ability to do work, and work is defined as force times displacement. So that's what energy is, and then the key rule about energy is that energy cannot be created or destroyed. It can only change form, or be transferred from one form to another. So for example, if we have an object up high and it falls, you start with a set amount of gravitational potential energy and it gets converted into kinetic energy as it falls. The store of gravitational potential energy empties into the store of kinetic energy, and you may have some spilled almost as dissipated as wasted energy into heat in the atmosphere. So let's think about this car then. Okay, so the car is running on a battery, and the common mistake here is to say that the battery contains electrical energy, but actually it is a store of chemical energy until it's put into a circuit when it gets converted into electrical energy, and then the car itself is going to convert that electrical energy into kinetic energy or movement energy. So I'm going to say,
how do the energy stores change? I'm going to say chemical energy in the cells of the car will be converted into kinetic energy of the car when moving. So chemical energy store will diminish, and KE store will increase. Just to absolutely guarantee I get those 2 marks. I've made 3 points, should get the 2 marks.
okay, next bit. The car has a top speed of 12 meters per second and a mass of 800 grams. Write down an equation that links kinetic energy, mass and speed. So here's where doing your Kahoots to try to remember the formula is going to be really helpful. It is the formula for the kinetic energy of anything, and that is kinetic energy, or actually on the AQA board I think it's EK, E little k, equals half the mass times the velocity squared. Okay, right, calculate the maximum kinetic energy of the car. Okay, so we're going to follow the standard procedure here. The standard procedure is to write your formula first. Even though I've just written it up there, I'm going to write it again so I can then clearly substitute my numbers correctly. Do I have the energy? No, I don't. It's what I'm being asked for. Do I have the number a half? Yes, I do. So I can just put in the half there, times by the mass, 800 grams. Now there's a problem here, because this needs to be in kilograms. So I divide by 1,000, and that will give me 0.8 kg. Okay, 1,000 grams in a kilogram. So 0.8 kg. Now, just as a little side note here, the only SI unit that you need to have with a prefix is the kilogram. So you don't need to do, if anything else is being given to you in kilo, mega, etc., you need to have it without a prefix. Anyway, so the mass was 0.8 multiplied by the velocity squared. Okay, so now it's get out the trusty calculator that you need to own. 0.8, hold on, 12 squared first, times 0.8 times a half, 57.6, and that would be joules. I'm going to round it to 2 decimal places. Okay, so 58 joules. Right, next question. Right, 7.4. Explain why having a more efficient motor increases the top speed of the car. Okay, so from your formula sheet, you should know that efficiency is equal to useful energy out over energy in. The more energy that gets converted from chemical to kinetic, the faster the car's going to go. So that's really what we need to get across. It's so energy is not being converted into heat; it's being converted into kinetic energy instead. So
if the car was 100% efficient, oh, whoops, was because I'm at 1s, I'm just getting distracted, was 100% efficient, then all the chemical energy in the cell would be converted into kinetic energy. Since the mass would stay the same, since the mass would be the same, the velocity would have to be increased.
okay, hopefully that hits that one as well. Okay, let's have a look. Last question, I think. Yes. So this is the last question. 4 marks. Figure 11 shows an electric car being charged. A driver wishes to buy a new electric car, hopefully not one of those. It looks a bit rubbish. Table 2 gives some data about an electric car and one with a petrol engine. So we've got the electric car. It's the cost brand new, £27,000. The running cost per year, £250, and the average lifetime about 12 years. I'm not sure if the batteries really last that long. The petrol car is quite a bit cheaper, £15,000. Costs quite a lot bit more to run per year. Lasts about the same time. Which car would be most economic over its 12-year lifetime? Use data from table 2 to support your answer. You should include the difference in cost in your answer. Right. So we're going to have to do some calculations. So I think that what I would do here is I would start thinking about these, adding maybe some additional useful bits of information here. So what's the difference between these two? So the electric car costs 2,700 minus 1,500, so it is, I can do it in my head, £12,000 more expensive. Just going to be a bit cautious because I do make silly mistakes with maths. Yeah, it's 12,000. So it's £12,000 more expensive to start with, right? I don't think I've got enough space here for this. Now, over 12 years, how much would you spend on running costs? So 12 times 2,000 is going to be £24,000, right? This is 12 times 2,000. Okay, so that's how much this would cost for a year. Sorry, how much this would cost for 12 years. It would cost £24,000. This one would cost, the running cost, so that's 12 times 250, 12 times 250, that would only cost £3,000. That's 24,000. I've missed a zero off. Okay, so that's quite a big difference. Okay, so let's try and work out how much the electric car would cost to buy and own for 12 years. So the electric car would cost would be equal to £27,000 plus £3,000 running costs. Now I want to show the examiner how I got my numbers here, so I better show them that I did 250 times 12, right? And that's basically the costs altogether. So that comes to a total of 27,000 plus 250 times 12 gets to 30,000, 3123 pounds. Okay, that's the electric car. Now let's have a look at the petrol one, petrol car. That's going to be its ticket price, how much it costs to buy on the showroom, plus 2,000 times 12. Right, so that's going to be a hell of a lot more. Okay, 39,123. Okay, pounds. Okay, so which car will be most economic to run over 12 years? You should include the difference in cost in your answer. Okay, so the electric car would be cheaper to run by 39,000 minus 30,123, £9,000 over 12 years. Okay, so hopefully that should hit all the marks for that. If you found this playlist with all the questions from paper 1 and paper 2 useful, please like, subscribe and share. Thanks for watching. Have a nice day.